welcome once again. In today's video, you will be learning how to use transistor in your project, especially connected to Arduino or other devices. It's quite important that you will learn how to use the right value of resistor to connect to the base of the transistor, and in order to protect your Arduino from supplying too much current to the transistor, which could damage the transistor, as well as to stop the load from drawing too much current from the Arduino. So it can also protect the Arduino. So you could see how very important it is for you to learn the right value of the resistor that you will need to hook to the base of the transistor. Let's get to it. By now, I think you all know that we will need a transistor. One of my favorites, the 2N222A, the TIP 120, and some couples of resistors that will be letting you know the value pretty soon. I also love to use the BC547 if I do not require to draw much load, like what I used in the transistor in the demo that I used previously. All right, let's get to it. To calculate the resistor value that you will need to connect to base, you will need to follow just these two steps. First, find the key variables that you will need. Then you will, apply the formula. So the first thing you need is you have to find out what current you will need. That is, what will be current of your load? That's the current of the load. What will be the trigger voltage connected to the base? That's the pins voltage from Arduino or Wemos, or if you're using a switch, what will be the voltage that will trigger the base to come on? You have to also check the transistor datasheet for the following: the base emitter on the voltage, that's the VB on. So you're going to use the maximum rating there. The DC current gain, that's the UHFE. You also use the minimum value in that case. So an example would be the current. For example, I want to power an LED bulb, and I would like to use a BC547 transistor. So I know the current that the LED will need, which is my load. That's about 20 milliamps. What will be the trigger voltage connected to the base? I'm using the Wemos D1. The Wemos D1 supplies, or it's a 3.3 volt logic, so it should give out or produce 3.3 volts at the time I turn on the LED from the Wemo. Now, I will check the data sheet, and after checking, you can tell that the rating, the VB on rating, that's the maximum rating of the VB on the data sheet of the BC547. Yes, VB on, I'm having 7 milliamps. So millivolts, forgive me. So I have 700 millivolts. That's about 0.7 volts. So that means that I will also check for the HFE. That's the DC current gain, which is the minimum value I'm seeing is 110. So I have the values I need from the data sheet. It's time to now calculate the resistor value. First, I need to find divide the current load, that's 20 milliamp, by the value, the HFE value, that's the DC current gauge, which will give me about 0.18 milliamps. So now that I have that, I also now need to use the Ohm's law, because I know the forward voltage of the diode in the transistor will take about 0.7. That's the base emitter on voltage. So I will lose about 0.7 volts when I use the transistor. So I have to subtract it from the 3.3 volts. That's the trigger voltage from the Arduino. The trigger voltage is 3.3 volts. And remember, we want to check the base emitter on voltage, which is about 0.7 volts. That means I will lose 0.7 volts. I want to know the volt that will be left. That's based on the Ohm's law. So I'll be left with 2.6 volts, which I need to divide by the current, which is 0.18 milliamps. Remember, I am going to use it as ampere, not milliamps. So I have to divide the 0.18 by 1000. So when I get the value, I will use that value, which should be like 0.00018. You can approximate it to 0.00002. So you divide 2.6 volts by 0.0002 or 0.00018. So you will get about 14,445 ohms. Normally, when you connect this to your device, you might not get exactly 20 milliamp. However, you will know that within the range of 13,500 milliamp ohms to like 15,000 ohms will be fine. You might need to use your meter to check and be sure that your parameters are the best, that is within that range, to get the actual voltage and milliamps you need for your LED. When I connected this, I got about 18 milliamps and about 2 volts for the LED. So about 1.9 volts, which is fine for me. I don't want to drive the LED constantly at 20 milliamp. That's not too safe for it. So you're free to try this with another one. And let's try another one again to be sure that we understand the process. Looking at another method, for example, the high load driving TIP 120, which has the load voltage. Perhaps I want to power an LED strip, which might be about 780 milliamp. 780 milliamp. That means I'll be dividing 780 milliamp by 1000. The HFE of the of the HFE, that's the DC current gain of the TIP 120, is about 1000. So once you find that on the data sheet, so that means I'll be dividing 780 milliamp by 1000, which should give me no brainer 0.78. So once I have 0.78, I know that my trigger is still 3.3. And looking at the data sheet of the TIP 120, I should have 2.5 as the DC, as the emitter base on voltage. So base emitter on voltage, forgive me, that's the maximum rating is about 2.5. So that means I'll be subtracting 3.3 by 2.5, which you gave me 0.8. Don't forget, as usual, even though we got 0.78 from the HFE, we need to now divide what we got, the milliamp, by 1000. So we'll be dividing 0.8 by 0.00078. And that should give you about 1k ohms. So you could be fine using 1k ohm to drive that TIP 120. Now let's get to practice using to see what the result will be on the Arduino using our meters also. Thing that's common with the BC547 and the 2N222A transistors, BGT transistors, you would notice that holding the flat side towards you, you have the base in the middle, the base, you have the collector on the side, and the emitter. So this base is where you connect the trigger, perhaps the Arduino, to the pins from the Arduino. The external voltage that you're connecting to this, perhaps the Arduino might not be able to control 12 volts, so you might need to connect 12 volts to this, then 12 volts output to your device. So that's just a simple calculation. Arduino source voltage to the load. That's just a simple trick. Now let's connect it and see how it works on the Arduino. This demonstration, I will be using a Wemos D1 using some jumper wires, my BC547 transistor, and an LED bulb. I also need, according to our calculation, about 14,500 14 kilo ohms, like 14,500 ohms. But I don't have that, so I have something like about 14,000 ohms, which you can see from my reading, about 14,100 ohms. So I will just go with that for now. So now that we have all the items we need, so let's get started. First, I'd like to connect my ground. First, let me just put a transistor so you see the proper placement. of the transistor. You have the flat side facing you. So you know that the far right is your emitter. That's the part that goes to your load. But I like my load to have the positive. So the longest part of the LED is the positive. So I'm going to connect that to the positive. As usual, the other end should have the negative. So my negative from I'll use the green for my negative. So I'm going to ground, and connected that. Surely you wouldn't expect it to come on now. Like I would like to use the 3 volts to power that. There's a 3 volt power that will connect to this LED, and I'm getting that from the board. I have a 3.3 volt logic over here that I could use. Good. All right, thank you. Got a 3.3 volts connected. Now, this is the time for the trigger to do the work. And I like to connect my resistor first. So I have the resistor connected to the base, the midpoint. Remember the middle? That's the base, and that's the reason why we're calculating all this to know this is the main part of the task. So I've connected my resistor firmly in the breadboard. So I have my resistor. You can see I have my resistor connected to the base, the midpoint. I have the 3.3 volts connected to the 3.3 volt pin on the Arduino. We must bought 3.3 volt logic. I have the emitter part connected to the positive side, because remember I took positive from there and I'm expecting it to flow to the other side of the Arduino of the pin. So the positive should connect to the emitter. Then I have the negative, which is that's the ground connected to the ground pin. So the last part I need to connect should be my pin 4. That's what I used. That's D4. So it's connected now. So I'm going to connect that to the resistor, and like you can see, it works. So that's how to just connect it. Perhaps you don't know how to connect it. I might use my meter to show you how many volts it reads, so you can understand that it's very important, and it even helps you. You don't have to start calculating the resistor value for the outputs. It saves the whole circuit a lot of stress. So, okay, you can see I have about 2.7, which you can still play with. You can decide to 2.7 volts consumed by my early. I can also work out the current, but clearly you should get, from the last time I calculated, I got about 18 milliamps, which is perfect for me. Thank you.